Hi, here we have in a class of 100 students, 73 like coffee, 80 like tea and 52 like lemonade. So this is sort of a Venn diagram question. So let's draw the Venn diagram. 73 like coffee, 80 like tea and 52 like lemonade. Okay, cool. Then it may be possible that some students do not like any of these three drinks. So there may be some people who do not like any of these three drinks. Fine. Then the difference between maximum and the minimum possible number of students who like all these three drinks. So all the three drinks is, let's say, A. This is A here. So we have to figure out the difference between maximum and minimum possible value of A over here. Okay. What can be the maximum possible value of A? Think about it. The maximum possible value can be the least of these three values, right? The least of these three is 52. So A max has to be 52. Not more than 52 people can like all the three drinks. Think about it. Can 53 people like all the three drinks? Well, 53 people don't even like lemonade. So how can they like all the three drinks? So the maximum value A can take is 52. Now what we need to figure out is the minimum possible value of A. Or let's say this is C. Let's say this is C. I have taken this as C. Now, let the number of students liking all the three drinks is C. Exactly two drinks is B. So, this region plus this region plus this region. All these three regions combined is B. And exactly one drink is this region. So these three regions combined, exactly one is A, and the number of people who like no drink is N. This is N. So we know C plus B plus A plus N should be equal to 100. And also, once you add 73, 80 and 52, if you add 73, 80 and 52, we know this will be equal to A plus twice of B plus thrice of C. Right? We know this from the Venn diagram maximization minimization part, right? So A plus 2B plus 3C is equal to sum of all these, which is 205, and also we know A plus B, A plus B plus C plus N is equal to 100. Now we know the maximum value of C is 52. Now we need to minimize the value of C. Let's see, can C be equal to 0? If C becomes 0, we get A plus 2B is 205. Now is it possible for A plus 2B to be equal to 205 given that A plus B plus C plus N is 100? So even if B is 100, even if you assume that all 100 people like exactly two of these drinks, in that case also A plus 2B will not come out to be 205. It will not come out to be 205, right? So what you need to do is C will not be equal to 0. C will have some value. If we assume C to be 0, sum of this will be maximum 200. It cannot be more than 200 if you assume B to be 100. So I hope you remember this from the maximization minimization. You have A plus 2B plus 3C has to be 205. If we assume B to be 100 and C and A to be 0, 0, this is 0, this is 0 and this is 100. So in that case the sum will come out to be 200, but we want the sum to be 205, so we have to increase the sum by 5 points. How can you increase the sum by 5 points? By transferring some of the people from B to C, because C has a higher coefficient. So if you transfer one person from B to C, this part will reduce by 2 units. If you reduce B by 1, this will reduce by 2 units. But if you increase C by 1 unit, this will increase by 3 units. So this decreases by 2, this increases by 3. So there will be effectively an increase of 1 in the total sum by transferring 1 unit from B to C. So if we want a total increase of 5 in the sum, we will have to transfer 5 units from B to C, or 5 people from B to C. So B comes out to be 95, C comes out to be 5, and A remains 0. So in this case, what will be the sum? Let's see. Twice of 95 is 190, plus thrice of 5 is 15. 190 plus 15 is 205. Hence, the least possible value of C minimum is 5 here. Okay, maximum value of C is 52, minimum value of C is 5 over here. So the difference between the maximum and the minimum value of C is going to be 52 minus 5, which is 47. Hence, the answer here is 47. Okay. So the highest possible value is 52, the least is 5, and the difference is 47. Thank you.